Welcome, everyone. Today, we are diving into one of the most powerful prompt engineering techniques available, constraint engineering, specifically the Impossible Constraint Challenge. If you're tired of generic AI responses and want to unlock true lateral thinking from Claude, you are in the right place. Let's get started. Let's begin by understanding constraint engineering. Often, when users want a creative solution, they give Claude a massive, open-ended prompt. But total freedom actually leads to generic, highly predictable answers. Why? Because language models default to the most statistically probable paths in their training data. To get breakthrough thinking, we must use constraints. By intentionally restricting Claude's options, we create what is known as productive friction. We aren't just adding rules, we are actively blocking the easy, cliché answers. This forces the model to explore unconventional solution spaces and generate novel combinations from its training patterns. Take a look at this flowchart. When you have a user problem and use an unconstrained prompt, the AI takes the path of least resistance, leading straight to generic output. However, when we apply constraint engineering, we introduce a bottleneck productive friction. This friction forces the AI's reasoning engine to bypass the standard logic branches and dig deeper, ultimately outputting novel combinations and breakthroughs. Building on the concept of productive friction, we arrive at the Impossible Constraint Challenge. This is a highly specialized prompt engineering technique. What is it? You ask Claude to solve a complex problem, but you aggressively strip away the foundational resources usually required to solve it. For example, you demand a solution with zero budget, no new technology, implemented by tomorrow, and that creates no new problems. Your human-first reaction to this will likely be, that's impossible. But here is the magic. Claude does not feel human defeatism. It doesn't get stressed. It simply accepts the boundaries as facts and objectively hunts for the creative solution hiding inside those constraints. It shatters fundamental assumptions. This mind map visualizes the core pillars of an impossible constraint challenge. We target three main areas: resource limits, like demanding zero budget or no new tech; time limits, requiring overnight implementation; and impact limits, such as forcing the solution to work for opposing user groups while creating no new problems. Layering these together creates the ultimate creative crucible. Why do extreme limitations work so effectively with models like Claude? It comes down to how large language models generate text. Without constraints, an LLM traverses the highest probability paths. If you ask for a marketing strategy, it will say social media ads because that's mathematically common. But when you explicitly ban those standard paths by saying you cannot use social media or spend money, you force the AI's attention mechanism into unconventional solution spaces. You effectively push the lower probability, highly creative ideas to the top of the generation queue. This technique creates structured, creative pressure. You aren't randomly brainstorming. You are systematically closing the obvious doors, forcing Claude to squeeze through the one innovative window left open. Look at this probability routing diagram. Normally, the problem, need more sales, flows easily into running ads or hiring a team. But our constraints act as concrete blockers on those dashed lines. Because the AI cannot traverse those paths, it is routed downward into the low probability / high value tier, discovering the breakthrough idea of leveraging existing client networks. Now, how do we actually write this prompt? Structuring the impossible prompt requires absolute clarity. You must define the core problem, and then list your constraints as non-negotiable laws of physics for the AI. If you leave ambiguity, Claude will find a logical loophole, and you will lose the productive friction. The framework is simple: solve problem with these impossible constraints. Then, number them. A sample prompt might be, solve our user retention drop with these constraints. We cannot alter the software code, and we have $0. If you are doing a massive ideation session, you can use the constraint magic approach. Ask Claude to generate a list of ideas, but force it to solve the entire problem using only one specific, bizarre limitation. This sequence diagram shows the prompt execution architecture. The user sends the core problem, immediately followed by the impossible constraints. Inside Claude's processing layer noted in the middle, the model evaluates these constraints, actively discards its standard training paths, and synthesizes a novel approach. It then returns a lateral solution back to the user. This is perhaps the most important slide in this training. Once Claude gives you a brilliant lateral solution, you must enter the reality check phase. What is this? It is the mandatory human evaluation of the output. While the AI's suggestions might sound incredibly clever, remember that Claude lacks actual real-world physical grounding. You must evaluate each suggested solution for actual, practical feasibility. Why? Because many impossible constraint solutions sound perfect on paper, but require significant modification for real-world implementation. An AI might suggest an elegant financial workaround that violates local tax laws, or a physical process that defies gravity. Your job as the human expert is to act as the implementation filter. The AI shatters the creative block, but you must build the bridge to reality. Here is your reality check filter in action. You receive the AI breakthrough concept and immediately pass it into the yellow decision node. If it fails physics, laws, or compliance, you discard or drastically modify it. If it requires tweaks, you apply human refinement. Only when it passes your expert evaluation does it move to the green node for actual strategic implementation. Let's look at a real-time, highly practical use case, the business reframe. Consider Jennifer, whose consultancy was struggling and needed rapid growth. The standard advice is to spend money on marketing or hire a sales team. Instead, she used the impossible constraint challenge: save my business with no marketing budget, no sales team, no new services, must be profitable in 30 days, and can't work more hours. By banning standard growth tactics, Claude was forced to identify overlooked resources. The AI suggested leveraging her existing clients as a referral network using a profit-sharing model. But remember the reality check. Jennifer took this clever idea, evaluated its feasibility, and modified the profit-sharing approach for legal compliance before creating a systematic implementation. The constraints sparked the breakthrough, but human expertise made it real. Follow Jennifer's journey on this map. In the first phase, she faces a massive block. Her business is struggling and standard fixes are too expensive. In the middle phase, she applies the impossible constraints, forcing Claude to explore overlooked assets. Finally, in the execution phase, the AI suggests the client profit share, and Jennifer expertly modifies it for legal compliance, leading to successful implementation. Even senior experts must recognize when advanced techniques fail. You need to know the failure modes of constraint engineering. Watch out for constraint confusion, where the AI's solutions begin to completely ignore your practical requirements or the boundaries you established. Also, beware of complexity for complexity's sake, where your prompt becomes harder to manage than the actual problem. How do you recover? You simplify the approach. If Claude starts hallucinating wildly or talking in circles, you have overconstrained the model mathematically. Return to basic prompting methods, back off one or two of the impossible rules, and give the reasoning engine some breathing room to find a valid path. This state diagram shows the delicate balance of prompt engineering. You start in the effective constraint state. If you push too hard, you fall into constraint confusion or the complexity trap. The path out of both failure modes points directly to recovery. Simplify your approach and remove a few rules to return the system to a balanced, highly effective state. To summarize, the impossible constraint challenge is your ultimate tool for bypassing generic AI logic. By applying extreme limitations, you force Claude to generate creative breakthroughs from the depths of its training data. Your action plan for this week: identify a stalled project and apply impossible limits, like a zero budget or a 1-hour timeline. Crucially, always remember to run the reality check to modify those AI concepts for actual real-world feasibility and legal compliance. Thank you for joining me in this masterclass. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides. See you next time. Our final roadmap to mastery. Start on the left, identify a stalled project. Move to applying extreme constraints. Generate your AI breakthroughs, and then immediately run your human reality check. Once you've implemented your brilliant new strategy, the final step on your journey is to visit quicktechie.com to continue leveling up your tech career.